Okay, so the last few videos were pretty much focusing on Fuchs distribution, different types of Fuchs distributions, and dealing with quantitative data, aka numerical data, those are counts and measurements. So now we get to two other unique plots that are out there that is commonly used outside of the box plot. Which definitely these two graphs here are very common for and very useful for bringing back original data, and about also having a good idea to try to give a good description shape in general understandings. But what we're definitely seeing here is when we're doing these graphs right here, both of these guys are going to do something very nice for us. And what they do is they actually plot the graphs of the values from lowest value to max, so to make them in the same order. However, we're not grouping them in groups. We're actually still showing their original values. While this one here doesn't group in groups, while over here it's being grouped into groups, but they're going to be actually still giving back the original values. So I know exactly what the data is, so I could do percentile ranking and do other things compared to what a histogram would have, or a group histogram for the most part, or a group distribution. But I'll show you how those things are working, how we're gonna find out how this right here is actually a histogram in disguise, but it actually gives us the actual data, which is the beautiful part about assembly products, and then you realize why this is my favorite one of all of them. A second to the box plot. Okay, so but the first thing first, we're going to sit here. Remember that said we're going to be sorting from we're going to be arranging the data from least to greatest, min to max. So I'm going to first show you guys how we can actually do it on automated calculators. So the Casio, the TI-84, and also the TI Inspire. So first thing first, if you have it to do so, please make sure you have the data in list 1. So make sure this goes into list 1 of all things. So if you want to make a new document, make sure that you first put this into list 1, all of them. Okay? So if you need to, pause the video and do so. Put it into list 1. So at this time, I'm trusting that you have this in list 1, because all mine are in list 1. And we're going to show something very nice and interesting, how the calculator can actually sort data. And we'll see it is very beautiful. And I'll also show you how to duplicate, so you can see we can compare the two. So first and first, I want to show you guys how to do the Casio. Then I'm going to do the TI-84, then the TI Inspire, because Inspire actually does something that's pretty nice. It tries to do something that's pretty nice, but it doesn't really get it almost all the time. But we'll see that when we see it. But anyways, I'm coming right here. And once again, I'm in the statistics mode, so all you gotta do is go to mode and go over and hit statistics. So you can get your statistics and tables, or right here, it's just your list and statistics. So now over here, notice how I was building mine horizontally, row by row, or just say column by column. So that's what's happening here. But notice how these guys are not sorted. It's 32, 22, 11, 47. These are not sorted. So me trying to do this by hand will take pretty much this amount of time, and who could also lead to error, because you might actually be including things, and let your exit things out. Got you. That's one way to keep organized. You slash out the things you know. What we hear is the beautiful thing is you can actually sort it on technology, and it'll help you out so much better. So what we do right here is I'm going to duplicate this list 1 to list 2. So I'm going to do is over here in list 2. I'm just going to write over here and in it. Delete that. I'm going to write shift list 1. And the cool thing about it, it's going to duplicate it, which is awesome. So let me go ahead and do that real quick. Enter, and there it is. List 2. I know it's already the same, but I'm going to do something with list 2. I'm going to sort it. So how do I sort? Well, first thing first, it's actually here in the tools. We'll put this thing. So if you hit tools, well, first thing first, where does it come from? So let's go and second quit so you can see where it's coming from. Or that was not second quit. So so this is what usually we'll see, and we don't see much here. So what we're going to do here is I'm going to hit the forward button, and notice right here I see tools. So under tools is where the sorting is at. So hit tools, and we see right here, sort as, So let's ask, which is short for ascend. We have over here sort des, which is sort for descending. These are our two sorted ones, so I'm going to do sort for ascend. Okay. And what I'm going to change is, I'm going to just pretty much change this one to see how it changes. And therefore, this one's going to change, enter. So select this number, 1 again, enter. So now notice how every single data is now in descending order. The first one is 11, followed by 18, followed by 2 22s, 21, 20, and I'm going all the way down. Notice how it's just constantly increasing, ascending order until we get to our max. So here's another way you can find your min and max without having to do any type of data. I can say, hey, let me just sort it. Okay, as we sorted min and max, which is awesome. Okay, so once again, if you need to, pause it and rewind. But all I did was, I had it in the main menu, I went to the arrow and I did tools. It's under tools. And that's how you can sort on your Castillo. So let's go ahead and bring up my TI-84 real quick. Let's see how does it happen over here. TI-84 and Inspire and Performance are very, very similar. And TI-83, if you have TI-83, it's definitely pretty much similar. So I'm going to turn this sucker on, bring it on a little bit. So it shows the list. Voila. Okay. So notice something over here. I'm going to still do the same thing. So if you want to learn how to copy a list over, you can just come over here to this list right here. And notice how I have it here equals. Just press enter. Now it's flashing, and I can say list 1. I copy it over, and there it is again. I copied it. So what I'm going to do here, I'm going to go to sort. So in order for me to sort, I have to go to statistics. So I'm going to hit statistics. And we see right here as the second option, under edit, sort ascending. So sort A means the sort ascending. Sort D means sort descending. And it's in order. So I want to ascend it from min to max. So I'm going to hit enter. It's an actual, what should you want to sort? Well, I want to clearly sort list 1. That's what I'm going to do. So I'm going to sort list 1. So second 1, list 1, and I'm enter it. So it says done. When it says done, it means I have successfully sorted it. And let's see if that's true. So now we'll go back to statistics. I'm going to go to edit, and is it done? Yes, it is. List 1 is now in the descending order. From 11 all the way to 84. It has been ascended. So we got those two out the way, which is awesome. So the next one is, okay, how to do a graphic calc, the Inspire. Similar things happening. Okay, similar thing. So over here, we can do the same thing in here, but you have to understand that if we're going to do in the list, you have to get rid, if we want to adjust that list, you're going to have to get rid of the equation that comes right here. What I could do inside here, and then do something in the equations, I could put list 1. So first we can put enters, so it shows the equals. And I said, well, I want to be the same as this 1, so I'm going to write out 1. I want to enter it. It's going to ask, what do you want to do? This is one of the reasons why I rather just copy it on the other side. And I'll show you how right now. So this right here, if you're going to do it through here, you have to understand that you can't do cells, you have to do variable. So you have to choose variable. Variable say every value in the list is going to be affected. That's what we want. So variable. And now I have it okay, and there it is, it's copied. But the problem is, if I need to make any changes here, adjustments, I gotta come up here where the expression was, and I have to clear it. It has to be cleared. Okay, sorry, it's a little too high. I have to clear it. So over here, just clear it, by doing second clear or control clear, it's gone. So now I can mess around with all these guys without it saying, oh, you gotta change everything. But that's out the way. I'd rather just do it on the outside and then just relabel it as such. So this one's supposed to be list 2, so I'm gonna label it list 2, so in this case in the future, I can use it. Okay? So once again, how do I sort this one? It's very similar. So the one I want to sort is list 1. So you don't have to necessarily indicate where it's at, but I'll put it just in case. So what I'm gonna do here is I'm gonna go to menu. And under menu, I'm gonna go to statistics. I'm gonna enter it, and then over I'm going to go back, go to data. And under data, we have over here, list operations and list math. So I believe under list operations, let's enter this real quick. Do I see ascending? No, I don't. So it has to be in list math. Let me just go back to it real quick. And see if it's in here. Oh, it's not in here. How did we do last time? Okay. Give me a few seconds. I'll find it. Sometimes my memory gets messed up when I'm looking at different type of graphs. So give me a few seconds. Oh, the captions. Sorry, I literally forgot, but I'm gonna find it right now. Because I know I was doing it a couple times already. I was want to say this was short. Come on. I know you know what it's doing. Just use your brain. Ah, there it is. So it has to be over here in calculator. You have to be calculator mode, not the other one. Because when I was in the other one, it wasn't showing that in operations. But I'll put myself right or wrong, sorry, but being in calculator, calculations. So once again, where am I located? I'm located in the calculations, not the list. So I do menu, I go down to the statistics, and it's under operator, list operations. So I enter it, and there it is, list sort ascending. I put it there, it's gonna ask you what to sort ascending. First, I have to put in parentheses, and I'm gonna say list 1. Just be consistent. Enter it, it says done. So what does that mean? It means that when I go back to my data set, it should be in ascending order. And there it is, ascending order. So when you're setting for this one here, definitely put it in your calculator portion. Because I've tried to find it through the data, or the list one, and it wasn't there. So, now, well, I'm going to end it with the TI Inspire, because the TI Inspire actually does its best at making a dot plot. Sometimes it does a good job, but other times it's bad in terms of its own scaling. And when it makes its own scaling, it has its own limitations, which is its own fault. Rather have some controls for some time. But anyways, what I'm gonna do here is I'm gonna be making a new graph or a new page. So I'm gonna hit Control plus page plus page for new page, add a page, and I'm gonna go over here and click on data statistics. Enter it. Notice over here we see all this stuff. It is definitely not a scatter plot. This is something totally different than a scatter plot. You see scatter plot in the future. Here is just placing data wherever it wants to place it. What we're going to do here is we have to come down here to the bottom where it says, click to add variable. So I'm going to click on this region, and once again, my variable is list 1 in the setting order. So I'm going to enter. I'm going to make sure I choose list 1 and enter. And notice how it is now something that looks like a dot plot. Okay, we have dots. Only if I can resize the points or even adjust the scaling, that'd be great. And I'll just zoom out and in, or do left right. However, if you want to see what these are, you could put your mouse over them, but then that could be a little hectic sometimes because you're moving a little bit slightly, and it's kind of hard to control sometimes. So there's an alternate way of figuring out what these numbers are by going to what we could refer to as a trace graph, a grass trace. So I'm gonna go to menu, and then I'm gonna come down here to analyze. And the last option, which is right here, which is permanent, you can press A or go ahead and highlight it. You enter it, is now a trace. So notice we have a bold dot here. Instead of the mouse going to be bold, we can now move the directionals. So when I go to the right, it goes to the next one in the list that is provided. So if it's not sorted, it's going to be jumping around. and you don't want to make it jump around, so it's sorted first, so it goes consistently straight. So now it's going from 11 to 18 to 20 to 20, then 21's on top. A lot of people think and assume that, hey, I think there's going to be 3 20s right here, or there should be 3 21s. That's not true. The only reason why 21's up there is because there's not enough space to put it right there between 20 and 22. So it stacks it slightly to the side. So it doesn't mean it's on, it has to be right on it to be a stack. Okay? So that's one thing you're noticing here for 21. But also, when you get to 25, you see 25, 25. You would think the next one is 25, but it is 27. So that's where the TI has this little issue, but it's a flaw. But it does this good job of, a good attempt of making the dot plot, which is great, which is what I commend about it. So what we're going to do, we're going to make it better. And somehow at the same time, I misplaced my blue marker. But there it is. So let's try to get this happen. Remember, this right here is your list. Over here is supposed to be your frequency. So what we're seeing here is, well, in this region right here is supposed to be the measurement of our x variable. What's our x variable measurement? Pretty much looking at time, which is in minutes. Okay? So over here you can write time, or driving time. You want to be more descriptive, so time, and pretty much I like to just write in minutes. Bam. So now everything is interesting. Notice how they went based off 10, counts of 10, which is nice. I can do counts of 5 to make it a little more accurate, and I'll just be doing grids. So I'm just going to together so I can get more spacing in between. Okay. So obviously I know this is 0. Then I can let this be 5. Then we have 10. Then it will be 15. Then I'll bring this down a little bit. 20. I'm trying to make like even space as possible. 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Okay. So I'll pretty much try to use the whole thing, give it even scale as possible. The grid is going to be very important, especially when you do a dot plot. You better have a grid. You better have a scaling because you want to make sure your graph looks straight. But we get dot plots later, but scaling is always important. Like I've been saying since histograms, since we've been doing polygons, histograms, and organs, scaling is important. So now I'm going to go ahead and do a frequency count up here. So you can kind of say, okay, we can let this be our dot plot. So we can say, well, this region could be 1, 2, 3, 4, 5, 6, 7. Okay, and this would be our frequency, which are your y values. And I forgot to put x values over here for the measures. These are the x values on the x-axis. So when I'm stacking them, I'll make sure they're consistent. So you don't really need the scaling here; it's not really required. Usually, they don't have a scale, but we know when we're stacking them, if that's the case. Okay, I'm gonna try and keep consistent. But anyways, here we go. The first thing we see in our list was I'm gonna go to the actual list because it'll be a little bit easy for me to read, and I'll get one of these other ones to show it. But I do this one anyways, so screw it. Over here in the data set, we're going to get something like this, okay? And we're going to do it ourselves. So first one is 11, 18, 20, 20, 21. So, where's my green? So, we're saying 11. Well, 11 is a little bit past 10. So it's 11, 12, 13. So I need 14, so I have to divide by 4 if you want to make it nice. So, therefore we have our 5 regions, scales. So we know 11 is pretty much in this region right here. So, therefore I'll put one dot right here. Okay. Next, we have is 18. 18 is pretty much close to 20. Okay, so 18 I could put this dot right here. Next, we have 20. So at 20, we have a dot, and then we have another dot. So also the reason why I'm using these scalings here, because I could keep consistent. Usually people won't have the scales, they're jumping everywhere. But you're stacking, like if you ever play tic-tac-toe on Connect 4, how we stack those little pawns or those little discs, same thing. Or chips, same thing. So where we're at, 21. So I'm just putting here to get my spacing in. So 21 is like right here, so it's pretty close to 20. So it gives like an illusion that there's two dots here, but there really is only, there's one dot, but there's really two there. And that's the reason why the calculator ends up stacking on top, because they get a little too close. And that's because of scaling. That's all it is, because they are scaling. Now I'm gonna get the rest of them in here. So we've got 21. Next is supposed to be 22. So 22, 25, 25, 27, 30. Let's get those in here. So 22 is right next to 21, so it's pretty nasty. So 22. Then there's two 22s actually. No, 122, two 25s. So 225, so 1, 2. Followed by a 27. A 30. Next, we have 32, 35, 38, 40, 43. There are 2, 35, 38, 40, 43. Let's get the other ones in here. Alright, the last of them. So 47. (47), 54. Wait, what? You got 54? (65). Well, you know that's over here. And the next one is 84. Okay. So there we go. I didn't put the 5s in here, but I did kind of start over here, but it's just grid. We know in between the 10, the 20 and the 30, half of it should be 25. So therefore, was it too difficult for me to do the hedges or the scaling? I don't like to write a lot, so therefore I don't want to write all of them. I just did the jumps. But there's my dot plot. Okay. So the beautiful thing about the dot plot, it helps us see where majority data is, and it helps us have a good visualization to is there any possible outliers, which we're going to learn in chapter 3. And we're going to find out later on in chapter 3, when we actually see this data again, and we actually make dot plots out of this one, we're going to find out that this sucker right here is actually an outlier. It's the max, it's the maximum, but you're also going to find out later on it's also an outlier. And we'll see how this outlier affects the mean of the data when it comes down to it. This one here, you might assume it's outlier, but it turns out it is still pretty close to majority of the data, and we have a formula that's going to prove that. But anyways, don't worry about that for right now. And we're obviously going to see over here, we're going to see the same thing happen, which is pretty tight. But anyways, we're good. We got that out the way. So if that's how the dot plot is made, cool, and it was made through the sortant, the assembly plot does the same thing. But the assembly plot, what it does is we're picking up a barrier line. Okay? And what we're saying is the barrier line is going to be okay. What units am I going to let be the leaf? If it was decimals, it should be the lowest decimal, but sometimes you round it and do some guesstimations. But usually it's the most smallest unit space, okay, or place. So over here, we're looking at what's the smallest place? Our smallest place is the ones place. That's the smallest place we have. If it was the tens place, the unit would have been, the leaf would have been the tens place. And I'll do a little side example here when I'm done with this, and so you can understand what I'm talking about. So all I'm saying here is, well, we're going to be breaking this guy apart. Okay? So we know that the 30 happens to be in the tens. So we know that if I do 30 times 10, or sorry, 3 times 10, I'm going to get 30. So in the tens region, over here, instead of me writing 30, I'm just going to write 3. Because it is the product of 10. So when it says the tens place, where all these values in here we're going to get, we're really saying multiply times 10. That's what we're really saying to do to get its value. And then we're going to get multiply that by 10, and then we're going to add, and then we're going to get, where this guy here is pretty much the multiple of 1, because it's the ones place. Okay? That's how it really works. That's how the assembly plot works, which is pretty cool, but it could be confusing for most people because they don't really know how to connect it right away. But that's what we're doing here. So we know this is your 10, well, this is your 2, which is 2 times 1, which is still going to give back 2. So when I add these two together, I'm seeing 30 plus 2, which is 32. So it's giving it back to us. That's what it's doing. That's all we're doing. All we're doing is breaking it up. So the rightmost unit, which is the smallest place, will be in the leaf, while the rest will be on the other side. So that's why sometimes we tend to just have it based off, sometimes we have to do rounding if it's 100. So therefore we round to 10. So we could have 10s over here and 100s over here. So sometimes rounding does occur depending on efficiency. Okay? But anyways, let's have fun planning, doing this. So once again, we could go from here, but the coolest thing is I kind of write on my numbers over here. So I could just go and read this dot plot and we can get the same thing. Because we can always convert from dot plot to assembly plot pretty tight, pretty close. Anyways, so we're over here, this was supposed to be 11. So what I'm seeing here is I'll put a 1 here, and I'll put a 1 here. This means 11. That's what it means. Okay? Next, the next one over here was supposed to have been at the 18, which is right here. So therefore, instead of me writing 18 here, I'm going to say, I'm going to put 8 here. So now what it is saying, this list contains 11 and 18. That's what it means. That's everything in here. So that's what, I guess we'll go with that, that's the most consistent one. So I'm saying here, what does this mean at the end of the day? This means that it came from the values or data, okay, set of 11 and 18. That's all it says. That's all it means. Okay, it's just set up differently. But that's what it means. If it repeats, pretty much repeat because that's what we stacked in the first place. But let's go ahead and get the rest of this graph in here. So I'm going to need some spacing in here. So I'm going to put 2 for 20s, 3 for 30s, 4 for 40s, 5 for 50s, 6 for 60s, 7 for 70s, 8 for 80s, and the last one we were in was in 80s. So I can stop there. So with 90s, I go further. But that's what's happening there. So now we're in the 20s, let's get the 20s in here. There was no 20, but there was definitely 21, so if I wasn't mistaken. I don't think there was any, there's 20. There's 2 20s. I must be blind. But there's 2 20s right here. So therefore, I'm going to write 2 zeros. 20, 20. 0, 0 means 20, 20. There's 2 20s. Next was 21, then 122. So I'll be writing 1, then 2. Okay. Followed by, over here, it appears to be right on the spot, so we're going to do that 25. So 2 25s, which should be matching because there's going to be 2 25s over here, 25 and 25 over here. So we have 5, 5. And do we have any more than 20s? Yeah, we do. We have 27. So we're ending with 27. Okay, so if I do it one more time, and hopefully this is the build for it, even though this is the maximum one, what is all this saying? Well, all we're saying is it's coming from the value set of 20, followed by another 20, followed by 21, followed by 22, followed by 25, followed by 25, followed by 27. We're saying that all those values is right here, is represented right there. That's what it's doing. Next, where's the next one? 30s. Well, when we're in the 30s, well, I believe that this right here is a 30, and that we're going to be 32, and then followed by 34, and that should be making sense over here, okay, in the same order. So we have 30, 32, 34, and I'm going to check over here just in case, because sometimes my eyes do deceive me sometimes. So I'm in the 30 realm. So was I right? 30, 32, not 34, it's supposed to be 35. So my eyes did deceive me. Okay? So sometimes the events just come through here. So because those are the actual values. So 35 and then 8. And then over here, 140. And I'm just going to continue going back down. I'm going to join my cardio workout. So we got the 40. We have the 43. Okay. Next is 47. Then we have 54, 58. Oh, one thing, it's very important that we keep these stacked because you want to have the misunderstanding of, stacking. So it's 40, 43, oh, it's 40, 43, 45, and 48, if I'm mistaken, 47. 47 right here. And we're going to get 54, 58. So try to keep these guys as straight as possible because because that's where the comparison comes in, the dot plot. You want to keep them as leveled as possible. Okay. Because we just don't want to confuse ourselves with any misleading results. And then we had 165 followed by 184. So this should have all the data that we have. Let's count them. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All 20 are here. So what these graphs are representing the same data. Okay? Just that one is a dot plot, showing by dots. Whatever is a semi plot, showing by a stem, which is in tens, and the leaf, which is the lowest unit we're using, ones. And the beautiful thing is, both of these guys, they have just shown, give us back the original data. And that's the reason why I like them the most. Okay. And another reason why I do like this one the most, because I showed you before, it actually does resemble a histogram. And I'll show you that to you right now. Okay? Why I'm saying what I'm saying. So, I guess I'm a bus black. So, and what we're gonna see here, we're just, I'm gonna have to erase this part right here, you guys. So let me erase this. So I'm gonna need that. So I guess I could use green actually, but since I'm erasing this. Okay. Oh, these two. So you could imagine this being the x-axis. So what we're definitely seeing, what's been green, smart guy. So this region right here, it's actually our x-axis, the values, the score. This is your time, okay? Time in minutes. Okay, which is your x values. And it turns out this stacking right here is very similar to the box plot, is your frequency. It's actually giving you a count. And I'll put it right here in the bottom. This right here, what's happening within here is low-key our frequency. Our Y values. Okay? For the frequency graph. And we're gonna actually be seeing a histogram sideways, which is pretty cool. So come over here. I'm seeing, that's why we had to stack it, okay? Because you don't want to have any misleading results. I'm stacking them. So we're definitely seeing that this one here stops here. Okay? This one here, and we have a frequency of 2. Coming over here, it goes up here. And we have 1, 2, 3, 4, 5, 6, 7 of them. A frequency of 7. Down here, we stack them. And we're seeing 1, 2, 3, 4, frequency of 4. You notice how there's 3 more over here, giving us 7. That's the beautiful thing about it. When we're stacking them appropriately, we get pretty much a good looking histogram. 3, 2, 1. Clearly there's nothing here, so that's a 0 frequency. And over here, answer that way, is our 1. So we have our frequencies, it should actually equal 20 as well. 2 plus 7, 9, plus 4, 13, plus 3, 16, plus 2, 18, plus 1, 19, 0, 19, 1, 20. Beautiful. And notice how I'm making a histogram, sideways histogram. That's the coolest part about it. So if that's the case, what is the class width then? If it's really a histogram, what's the class width that we made here? And that's interesting to catch on to. Is sorry for blocking it. What's the class width that we made here? Notice how over here we said we went from 1, and over here, I'm sorry, which is supposed to be 10s, and then we had our 20s here. That's where it started. It started at 20. Over here started at 30. Over here started at 40. Over here started at 50. Over here started at 60. Over here started at 70. Over here started at 80. Okay? So we actually have our lower limits. If you don't realize that, we actually have our lower limits. It's pretty awesome. And then now we can actually get our upper limit. So there's always one less. So one less than this lower limit is supposed to have been 79. 17, one less, becoming 69. One less, 59. One less, 49. One less, 39. One less, 19. Oh, sorry, 29. One less, 19. And over here, most important thing, the next real upper limit would have been 90. So over here it should be 89. Okay? I was looking at a little asterisk saying that's unique. You want to know? Because I like to go based off real limits. That's me. I love real limits. But check it out. I actually have an interval. I actually have the intervals for the measurements and the corresponding frequencies. I actually can make a frequency distribution table just by looking at this. That's what I love about this is the reason why I love the assembly plot the most. It has the function of a dot plot, given the original, and it has the function of a histogram. That's the beautiful thing about it. So now the last question is, so if I know the intervals, what was the class width then? It turns out for this one here, we definitely see that our lower limit that it used for its for his conveniencing was 10. It turns out that the class width that we're looking over here, or interval size, whichever it is we're looking at here, class width happens to be, once again, you get the consecutive lower limits, aka real limits, and we go ahead and get 20 minus 10, which is 10. Our class width happens to be 10. What do you think about that? Okay. We have a histogram with a lower limit of 10 and class width of 10. Beautiful, amazing. I love it a lot. So therefore, that's why the symbol is my favorite graph of them all, because it's multifunctional compared to others. But anyways, that's the end of assembly plot and dot plots. Hopefully you guys understand and we're able to catch on to how assembly plot works and dot plots, how to graph. Once again, it's all through sorting. The sorting is our friend, it's going to be our key. Unless you want to do a needle in a haystack and X things out, you could definitely put data, get it sorted, so things become easy for you to just arrange them from there. Okay? So that's it. Thank you.